Example 6, we're going to find force. A 200-pound cart is on a ramp inclined at 30 degrees shown. What force is required to keep the cart from rolling down the ramp? Now, one way that we're going to work with this, the first way I'm going to show you, is that we could use a projection on of F onto V or U onto V, just like we did with the other example. But I think for this example, it might be better to instead use a different way to do it. So let's write down what we know. A 200-pound cart is on a ramp inclined at 30 degrees. So here is our 30 degrees here. And then the force, it's the force due to gravity. So important to know what that is vertical and downward. Okay, vertical and downward. So important to know what that is so you know what you are labeling. So the vector is F equals negative 200J. So if you think about here, just remembering that is at negative 90 degrees, right? So cosine is 0, so that's why it's a 0I. And then this is going downward, so that's going to be negative 200 and then J. So that's why it's just negative 200J. So that's what we know. We know that is 200. That force. And now what we could do is just let's use our triangles instead. So we know that's 200, so I'm just going to leave that there. So here we have this angle is 30 degrees. Now let's look at the triangles that they made. So this is perpendicular here. So this is 30 degrees, therefore this is 60 degrees here. And so what I'm trying to find is this force here, V, which is similar to our W1. So really I'm just trying to find my W1 here. That's what I want. And so if this is 60 degrees, this is 90, therefore here is my other 30-degree angle. Now what I'm trying to find again is this here. So what ratio can I write to solve this? So we want to know this. This is our opposite over this is our hypotenuse. So we can use sine of 30 degrees equals x over 200, and actually that's a negative 200. And so let's solve for this way instead. That's a little bit nicer, and you get the same answer. So x equals negative 200. What's sine of 30 degrees? Sine of 30 degrees, that is a half. So therefore, what you need is W1 is negative 100. And so that's how you want to solve this problem. And so if W is negative 100, then what we know is that what we need is that a force of 100, and what units are we in? 100 pounds is what we need to keep the cart up. Okay, a force of 100 pounds, that's what we need. So if W1, that force here is going to be negative 100, right, going down, then in order to keep it at 0 where it's not moving at all, we need to apply a 100-pound force that way. So try this example. We work example 6. Now I want you to do this by making a drawing and everything else to get you some practice for what's on the test. And so we work example 6 for a 150-pound cart that is on a ramp inclined at 15 degrees, or I guess if it is on the test, I don't know. And so go ahead and try this example out, drawing a picture and everything else. So we tried this out. Hopefully you got the picture here, something similar to that, or your own picture. So negative 150 is the gravity, the force pulling downward there. And then the angle was 15 degrees. And so if this is 15 degrees, and we know this angle is also 15 degrees, and then you solve for W1. So if we know that it's going down, whatever that is, negative 38.8, then we need to apply a force of 38.8 pounds. So now let's look at our last word problem, definition of work. The work done by a constant force F as its point of application moves along the vector PQ, and it's got the little line here, is given by either formulas below. W because of projection of PQF, times the magnitude of PQ here. Now, what else I want to add to that is that really is just the cosine of theta times the force times PQ. And PQ is really just our distance here. Or it can see W equals the force times PQ. So let's try an example. To close a sliding barn door, a person pulls on a rope with a constant force of 50 pounds at a constant angle of 60 degrees, as shown in figure 6.33. Determine the work done in moving the barn door 12 feet to its closed position. So we know that PQ, that's our distance here, is 12 feet. Theta is 60 degrees, and the force is 50. So really all we need to use is W equals cosine theta times the force times PQ. So cosine of 60 degrees times 50 times 12 feet. And so cosine of 60 degrees is a half times 50 times 12. So that is 600. So this is 300. And how you say it is foot to pounds. Okay, and so make sure you add your units there. So it's pretty fast, not too bad, just applying the formula there. So try this example. Person pulls a wagon by exerting a force of 35 pounds on a handle that makes a 30-degree angle with the horizontal. Determine the work done in pulling the wagon 40 feet. So it's cosine of 30 degrees times 35 times 40 is 1,212 feet to pound.